My name is Anirban Sarkar, and I'm working here in nCircle as Associate Vice President for Global Business and Strategic Accounts. And I'll be the co-host and moderator for today's webcast. Along with me, I have Apurv Chaudhary, who is technical manager and one of our Revit specialists, and of course Tom Cuneio, who is founder and CEO for 3D-IQ, and Tom has kindly accepted our invite to join the webcast and showcase about the MasonryiQ solution, which is built on Revit. So thank you, Tom, and thank you, Apurv, for joining this webcast. As a flow, I think we will just do a quick introduction of our companies, and then we'll move on to the specific solution of showcasing how Tom has been using this specific solution for solving problems in the masonry industry. So I'll start the presentation with an intro of nCircle. Tom, by chance, do you have my screen?
I do.
All right, perfect. Thank you. So we nCircle as a company, we have we have started our operations in the year 2012. We're based out of India and have customers coming all over the world, by the way. We have a team of about 130 engineers working with us, all software specialists, and having a knowledge of the construction and engineering industry, who has been helping our clients building impactful 3D engineering and construction solutions. We are a leading CAD BIM customization and 3D application development specialist, and we categorically work for the domains of construction, engineering, and 3D visualization. We have more than 60 customers coming from 15 different countries, and we have built more than 200 engineering solutions for our customers so far. Coming about a little bit of our relationship with Autodesk, we have a great partnership with Autodesk. We have worked with almost all the platforms Autodesk has for its customer, be it Revit, AutoCAD, Civil, Inventor, Navisworks, Plan 3D, Forge, Fusion 360, Max Maya. So that way, we have been working with Autodesk and its ecosystem partners, and the customers for last 7 years. Specifically, we have also been working with Autodesk as their software or product development partner. We have been working directly in some of their research and development projects, contributing in their R&D efforts. We have done a lot of application development projects extensively on Revit, AutoCAD, and other platforms that way. All these are more about building customized solutions or tools and plugins and productivity solutions on top of the CAD BIM softwares. Beyond that, we are also world's leading system integration partner for deploying Forge and certified by Autodesk. We have done more than 20 projects on Forge and many integrations with BIM 360 as well. A good 75% of our employee base has expertise with Autodesk technologies. I think beyond that, I would want to wrap the introduction of nCircle, and would want to invite Tom to share his part of story about his journey with 3D-IQ and Masonry IQ. Tom, kindly.
Okay, thank you, Anirban. I appreciate that. Right, as Anirban mentioned, we are one of those Revit solutions, and we've had a good history of making some really interesting progress and improving Revit. And that's really what I want to talk about today. So my story begins just very briefly. I'm a mechanical engineer. I was very interested in 3D modeling. And in 2003, I started a company called CAD Blocks. And the intent there was to do 3D unit level, so solid component level modeling in the CAD space for the masonry industry. We saw a great need in that area. And so we have since become the largest provider of 3D models for commercial masonry in the US. We've experienced a lot of interesting growth, and I will show you a little bit about what we do there. But that really was the background, that experience, these last 17 years of modeling masonry has served as the background for 3D-IQ, which is a company that I began in 2016. And we tried with this company to take all that we'd learned about modeling for BIM and automate it. Okay, so the largest hurdle still in pre-construction modeling workflows is just the effort that's required to put these models together. So 3D-IQ exists to try to develop software to introduce modeling automations so that we can really accelerate the model production process. And I'm going to just tell you that story today. So like any story, you start at the beginning, right? And so I guess if you had to imagine the way the next 30 or so minutes is going to go, we can think of an airplane coming into land. I want to start at the high level, just looking at BIM as an idea. And then I want to look at BIM as a solution, which is something somewhat different. We're going to continue down then with that background, and then start to look very specifically at masonry. So we're going to look at masonry systems, what those assemblies look like, how they go together. And then start a conversation about, what does it mean to model masonry? What does a BIM solution for masonry look like? And then we'll finally land the plane. We'll get directly into MasonryiQ, how the system or how the solution functions, what kind of input output we get from it. So that's kind of our journey today. So BIM at the highest level, I'll be very brief here, but we're trying to take a physical thing, a building, which is obviously a 3D object, but we have to document it, communicate. How is it going to be constructed? What is the intent? And so for hundreds, even thousands of years, that's been done in 2 dimensions. So we actually take something that is an actual object, and we deconstruct it for the purposes of documenting and communicating it. We have to do this just because of the format that we use to design and build, but there's certainly problems there. And so we wind up in data silos where we've taken data, separated it from its true kind of connection, and now we've got to maintain continuity in all these different places. So sections, elevations, plan views, specs, we've got all this information that's disconnected. The real world, obviously, is connected data. This information is all connected. If I change a component, it has impact on design, it has impact on cost, it may have impact on render, how things are going to look. So BIM is really just the idea that we want to put that data back together. So I got a little screen lag here, sorry about that. So BIM as an idea is the idea that all this information really ought to come back together. And it's only been in the last, say, 10 years or so that software and hardware has kind of arrived at a point where it was feasible to consider this. So we've been moving in this direction toward a whole new way to design and construct. And so like any process like that, I think evolution is a pretty helpful analogy. You know, if we think about biological evolution, there's really two key factors that stand out. One is time. Anytime you're making dramatic changes to any kind of a system, technological or biological, it takes time. And so we're seeing that as BIM is being implemented in the industry. It doesn't happen overnight, it's a process. The other thing that you notice with evolution is that it really involves a lot of death, at least on the biological side. A lot of experiments fail, and it's just a necessary process to find optimal solutions. And we're seeing that as well. There's a lot of point solutions out there in construction technology right now, and we're trying to find that path that will keep progress happening. So as we move from 2D into a future state of BIM, so we're not there, we're somewhere along the way, and I think that's a really important concept to carry through the rest of our discussion today. Is we're stuck between two worlds right now. We've left kind of the 2D design methods behind. We're moving toward a very clear and easy to understand point where we've got all the data integrated again. But you don't just snap your fingers. BIM isn't magic. You have to very carefully build all of the infrastructure that's required. And that's really what we're doing with 3DIQ. We exist to try to move this pen forward and get into this future state where BIM is fully implemented. So with the background kind of given there, I want to pivot here in the conversation. I want to start talking about a specific use case of BIM, which is its application to masonry. And I don't know if everybody has an understanding of masonry systems, so I'll just give you a little bit of an understanding of what exactly we're talking about. Masonry, of course, we think of brick, we think of block, stone. These are all, of course, cases of masonry. So what are we dealing with? We're dealing with pretty complex assemblies. It makes it a very interesting case study for BIM. We've got a variety of shapes, sizes. These are arranged into patterns. These patterns can be quite complex. That's what makes it a very interesting design material. We have a variety of color and texture to manage, so it's more than just managing shape and pattern. There's another layer of design that's imposed. And then you can see quite a few accessories, even just in this photo. A masonry assembly may have wall ties. If it's structural, it may have rebar. There's grout, there's mortar, flashing weeps. So a lot of pieces and parts go into a masonry assembly. So how do we model it? It's an important question. If we're going to implement BIM effectively, we need to be asking this question. So we see a little mock-up schematic here of a wall similar to what we saw in the photograph. We have to start making some decisions. How are we going to put this assembly together in BIM? There's a lot of information here. It has a lot of impact on structural design, on cost, on aesthetics. So we really want that information in the model, but can we really afford to model every piece and part? And I think the ideal answer is yes, we want all of that in the BIM. Unfortunately, it's impractical, and that's really a product of the tools that we have. Again, we're stuck between two worlds right now in our kind of evolution of BIM. So what we're trying to do is say, yes, we do want to model everything, but we don't want the data load, and we don't want the time and effort that's required to get there. If we could solve those two problems, then I think everyone would agree, yes, we want everything we can get into the model itself. That's not the state that we're at today. So let's talk a little bit about Revit specifically. I don't think this is unique to Revit. This would be true for any other BIM authoring tool that's widely used. But a BIM model in Revit generally stops around LOD 300. And LOD is just a scaling system that references how much 3D content is actually in the model. So what we really have is something more like design intent in the actual BIM model itself. That's not adequate for construction. We've made some simplifications. We've reduced assemblies into just single mass elements. We've had to do that because we're talking about a cost benefit analysis here on the design side. We don't have the tools or the contracts that would allow us to do, a higher level of modeling during design. So the way it works today is we have to get to LOD 350 for contract documents, so we fake it. We take the design intent that's in the model, and now we just go back to our old 2D habits, and we draw on top of the model just with 2D line work. So this is how we're creating sections, plan views, elevations. It's not ideal. It certainly isn't BIM, and this is the best we have today on the design side. It's really quite close to the 2D world still. Compare that to something like LOD 400, depending on the scales you use. That's going to look more like what we see on the right here, where we've got all the components actually in the BIM itself. We are absolutely very active in this space, but not on the design side of the construction cycle. It's only on the construction side. So how does this look? This is a project we did several years ago. This is the Revit model. So we're in Navisworks here. But you can see how little information is really in the design model. Again, walls are just mass elements. So what happens today is the design stops there, the 2D line work happens, and then a contractor comes along, and this is a CAD blocks model for this same project, where we've come along in the construction phase and actually reconstructed what should have been the design model for BIM. Now, there's tremendous value in doing this for construction, and that's why we see so much of this activity happening in the construction community. But you can see we've got individual components represented. We've got shapes that are unique at bond beam locations, chamfers, veneers, properly spaced, dimensionally accurate. Different bond patterns are represented here. We can get all kinds of interesting information from these models. You can see we've got vertical rebar. So this is our tensile load resistance in a masonry wall. So the rebar schedule from the structural engineer has been actually modeled and imposed into this world. And we're using these models, again, very effectively for production orders, for figuring out pieces and parts accurately, and then for doing clash detection and coordination. So we're bringing other trade models in, and now we're able to really solve a lot of problems. So this is a familiar workflow to anyone who works in pre-construction today, doing clash detection coordination. But I wanted you to see masonry models, how they're functioning, how they're being used today. Again, all on the construction side of the equation. And it really has changed the way construction happens. As I kind of briefly hinted at, we're using these models for production orders. Every unique shape, piece, and part is accounted for in the models. So we have an exact production order. We know exactly how to build now. This has eliminated maybe 20% or more of the material cost side, because prior to models like this, we just didn't have tools to get accurate enough. So we had a lot of add orders, we had a lot of waste. Models have allowed us to eliminate that. So pretty significant progress being made there. As I showed you in the video previously, we're also clashing and coordinating now. So we're understanding conflicts. Maybe there's a horizontal bond beam, which is a structural element in the masonry wall. Maybe we have interference with a steel model. Instead of finding those during construction, which is historically kind of how things went, we're finding those in a pre-construction workflow and models now. So it's a tremendous step forward. Then we're kind of going backwards from there now, and we're going back to 2D drawings. But these drawings have a lot more information now than design documents have. We've got other trades integrated into the model. We're able to show really what as-built conditions are going to look like prior to construction. So these drawings are becoming much more value. They're adding a lot of value, I guess, to the design drawings. And then we're even doing other interesting things. So there's a forward-looking kind of future component to this. This is a laser scan. So using LiDAR, we're scanning projects at some intermediate state of construction. So we're capturing as built from other trades. And then we're taking materials that are maybe still in production that are going to come to the job site, and we're checking them for fit. Do the trades that have come before masonry, for example, have they executed well enough that we're not going to have issues? If they haven't, we have time to modify a production order and avoid, kind of the waste that is part of traditional construction. So models are tremendously valuable for construction. That's, I think, the point that I want to make. So our business bears that out as well. So just a few examples here, and then we'll pivot away from construction. But I took a look at some of the projects that we're working on, right now at CAD Block. So this is a student housing at Santa Barbara. So a very nice masonry project. These are the type of projects that have great interest in the solutions that we're discussing. We're working on several large airports: Los Angeles, Denver, Salt Lake City. The Los Angeles project has over 500,000 masonry elements. That's not accessories, that's actual, units themselves. So very large scale projects are taking advantage of this type of technology. We're doing a couple of soccer stadiums in Nashville and in St. Louis. And again, these are ongoing projects right now. So we can see, again, that construction really values component level models. And this will be the final kind of point on this topic. This is a look at a McKenzie and Company report that was just recently released. It's looking at venture capital investment dollars. And so the darker squares represent higher investment dollars. And if you look at the row labels along the left, you'll see that as we go down the column, we're progressing through construction. So early conceptual design itself, pre-construction, construction, operation, and maintenance. And one thing that's very obvious here is that venture capital money is also very focused on construction. Okay, so this is the current world of BIM and how it's being applied. Very little focus on design and engineering, or much less, and even less on concept, very early design processes. And this is happening for obvious reasons. If we look again at this construction process from programming through schematics and on into construction, the cost of making changes goes up dramatically as we move along the timeline. We're always going to achieve like an LOD 400 state. It's called construction. What's happened in the last 10 years is that we've got solutions now that allow us to explore that LOD 400 world pre-construction. So you can easily understand the economics that are driving BIM coordination. All right, these workflows are just delivering tremendous value. Well, this is kind of where we are today. What's really interesting to us at 3DIQ is how far forward in the timeline can we push an LOD 400 model? If there's value pre-construction, how much more value is there to explore a model during design? The earlier we can understand issues, the sooner we get a handle on cost, the better decisions we can make, right? Our decisions are only as good as the information we have at hand. So by getting more information earlier in the process, we have a real opportunity. And so this is really what I call automated modeling. We want to take that model that we can't afford to build until construction. We want to build a software solution that can build the model for us. And then we want to deliver that model as a digital twin during the design process. This is the really exciting opportunity that we brought to nCircle and said, can we get there? And that's been the journey over the last 5 years. A final little, way to think about this. There's some interesting research going on in mathematics around chaos theory. It's called the butterfly effect. And this is looking at weather models. So building mathematical models to try to predict and understand weather patterns. And what they've learned is the initial conditions that they set for the model are extremely sensitive, meaning that very small changes in the initial conditions have very dramatic impacts on the final state of the model. And so the question is, can a butterfly flapping its wings somewhere in South America cause a tornado to occur, somewhere hundreds of miles away? But the point is that there's great sensitivity to initial conditions. And that is exactly what we see in design and construction. Little mistakes early in the design can have tremendous cost impact on what we actually build. And so all of this points toward getting those initial conditions in the BIM, allowing designers to have access to that. So for masonry, a lot of what we deal with in pre-construction is understanding design detail conflicts, section views, plan views, elevation views that are in conflict. This requires time, RFIs. It sometimes leads to things being built incorrectly. It's all a matter, or it's a result of deconstructing in the design process. Movement joints and control joints. These are elements in masonry designs that control cracking. They are very often neglected in the design package, so we're trying to tackle those things right on the verge of construction. Vertical rebar. Okay, this is the steel elements inside a masonry wall that give the structural tensile strength to masonry. They're very poorly understood in design, and we're exploring really what the design ought to look like as we build. Rebar is usually just given as a schedule. It's not even graphically represented in the designs. Same thing for bond beams and lintels. These are the structural elements that support windows and doors and openings in a wall. These are, again, they're generally just a table in the structural documents. They're really not graphically represented, and we see very often in construction where we have conflicts. Layout and fenestration. This refers to the patterns. Where do we locate doors and windows? Can we get them to line up with the pattern of masonry so that we don't have unnecessary cutting? This slows construction. It adds waste. It adds cost. It contributes to silica, which is a dangerous, it's a worker hazard. So all these things are not well understood during design. Material schemas. So how are we using color and texture? Generally is not well represented in the documents. And then budgeting. We're using tables. Okay, we don't have access to individual components in an assembly to budget from. So we're using local knowledge or we're using tabulated information. We wind up with value engineering. So as we get into construction, we're making changes to try to manage the budget. None of these things are in the BIM. This information is still locked up in the old 2D workflow. This is really the opportunity. How much of this can we actually get into the BIM? And it comes down to model cycle time. We don't do it in design. We don't get it into the BIM itself because the tools aren't available and the time required to do it with the existing tools is on the order of weeks or months, and that doesn't fit the economic model of design. MasonryiQ is a solution that allows software to fast forward the model into an LOD 400 state. So let's get into a discussion about how MasonryiQ works. We need the initial Revit model. I know that's a bit faint, but we're just looking at a 3D Revit model of a wall system in a building. You're going to go ahead and model in Revit just the way you do today. That provides input to MasonryiQ. It gives us wall locations, dimensions. It identifies wall types, shows us where doors and windows are. So this gives us all of the actual building geometry as an input. To that now, so normally a design stops there. We're going to go ahead and add the bond pattern information as an input to MasonryiQ, not just a graphic or I'll call it a wallpaper. Let's go ahead and make that pattern a mathematical representation of a pattern so that we can generate real components from it. Then to the pattern, we need to insert elements. And these elements can have a variety of different geometric configurations. They serve design purposes. Let's go ahead and add that to the model. We're building interfaces that allow you to capture this and feed it into the system. Same with our schema. Let's go ahead and let you shop from local producers. Let you browse the actual photography of their product line and put that into the model. Let's take the rebar schedule from our structural engineer and feed that into the system. So MasonryiQ now takes all of these inputs, it performs an analysis, and then it programmatically generates an LOD 400 model. So it's going to assemble a component level model like all the models I've been showing you for construction from CAD blocks. We're going to generate that in a matter of minutes. Now you have this model easily accessible during design. You can begin to understand the impact of the design assumptions that were made, and we can make really good decisions now because we've got much better information. We're going to do the same for rebar. Okay, so we're going to take the rebar schedule. We're going to build it out. It's going to be able to show us lap splices, bend geometry, where we've got multiple bars, if we've got congestion in rebar. These are things that there's really no visibility into in the traditional design process. Now that we've got a model and we've got it being generated in parallel to our design process, detailing can be automated. So we can automatically generate section views, plan views, accurate elevation views just from the model. We just ask the software to generate it. If I change a design assumption, so let's assume that we change something in the pattern, I just rerun MasonryiQ and I'll get new details. I'm no longer responsible for maintaining continuity or even just doing the work itself to produce the content. And now that we've got a handle on the components, we can very specifically understand cost. So we can now assign cost values to each element, and I'm not dealing with RS means data or local information that's really kind of an estimate. I really understand exactly what's happening with the cost picture. And this gives us the opportunity to maybe get rid of a lot of the value engineering that we see in construction. So this is kind of the opportunity that has been created with MasonryiQ. Better information, better decisions. And in fact, now that we can make changes to our design assumptions, so we can change any one of these bits of input, and we can rerun the model, we can now explore design concepts and understand cost and details. So there's a whole new world of opportunity that's created by having an automated modeling tool working in the BIM environment. So I just want to look a little more closely at each of these features, and then we'll turn our attention toward how this development was accomplished. So again, I mentioned patterns. We're giving you the ability to create patterns that work for masonry. They're mathematical patterns now. We can build models from them. They're not just hatch patterns or graphics. This allows us to analyze the geometry that's been fed in, and now we can begin to understand what kind of cutting happens. So we can see a lot of cutting here that we'd like to avoid. Maybe I can adjust window locations and eliminate these cuts. I'm going to get a better aesthetic, better performance. I'm going to save cost. I'm going to eliminate waste. These are things that we can now understand during design. I've got field cuts here. So you'll notice that the pattern is disturbed because the dimensions along this wall don't fit the pattern. These are things that architects want to understand better. Now they're getting feedback from their model, telling them what adjustments they can make to get a more efficient, more cost-effective, better looking solution during the design process. Unit geometry. We're able to feed any masonry unit shape into the system, and now the model can react and it can put the proper units where they're required. This is all done programmatically. we don't need the design community to have a better understanding of masonry. We're letting the software add that information to the designer. So we're giving them assistance. We're giving them trade knowledge. We're giving them access to codes, best practices. We're just programming that into their design tool. So it allows us to take a Revit model like the one you see here, again, put together the way an architect would do any Revit model. But now we run MasonryiQ and we get here. We've got this component level model. This model had over 100,000 masonry units. It took about 36 minutes to run this model. We're continuing to optimize and improve to bring that down. But this is a model that would have taken weeks, many weeks probably, to build, making it prohibitive. You wouldn't do it. But if you could do it over your lunch break and come back and have this understanding of the design, now you've got a lot of power at your fingertips. And again, that model allows us to do automated detailing. So that's a new opportunity. I don't need to put the time in, and I'm guaranteed no conflicts because it's coming from a single data source. Schemas, so material. This is the kind of masonry project that we're often looking at. It's more than shape and pattern, right? There's color and texture involved. We want to integrate this into the model as well. So we have a browsing capability inside the solution where we've got a host of producers throughout the US. We've got photography of all their products. We've got tens of thousands of images that are part of our business opportunity. And now we can browse those. We can look for content that we want to use. We can add it to the project. And then MasonryiQ will assemble that, and it will give you renders in Revit that look like what you're seeing here. These images are not, this is not photography of actual masonry. These are renders that are produced from photography from actual producers that you could directly specify on a project. So there's a whole new opportunity of engaging the owner, of allowing the architect to communicate and explore exactly what they're accomplishing with their design. This has been one of the most exciting features for architects that are using our plugin. Same for Rebar. So taking the Rebar schedule, feeding it in very easily as an input, letting the software take over in Revit. This is content that's generated in Revit. Sorry, I don't know why that didn't. This is content generated in Revit by the plugin. No manual modeling, no need to generate the Rebar content with Revit's existing families. The software will do that for you. And then finally, that gets us to cost. So with an accurate understanding of the components in the assemblies, we can now get a very clear picture of cost. Having a model like this opens up a few other interesting opportunities. One is control joints. These are, again, for controlling of cracking. They're complicated, but now that we've got a model where we don't have a general idea of how patterns work, we know exactly how patterns work. We can now add elements like this to the model with the software, let it automatically analyze and locate these joints. So we're able to do, code analysis, standards, rule-based kind of checks on models like this. We have a huge reservoir of information now that allows us to perform the kind of analysis that will really inform the design process. As an output from Revit, of course, we've got contract documents, we've got sections, details, all of that. But we can now export an IFC model that can be used for clash detection and coordination. So we don't have to remodel, which there's so much of this happening in construction today. We don't need to have another trade come along and start from scratch and start modeling. We can convert the design model directly into an LOD 400 model for coordination. This is going to be, a tremendous breakthrough in terms of having access to content. Coordination and pre-construction is very powerful, but it's still dependent on content. Trades have got to produce these models. We're at a place now where we're having software produce those models. So just to wrap up, a little case study. This is a very small, simple commercial project. This was the project as it was constructed. This is the model using MasonryiQ. We identified every cut, every piece, every corner, every shape in the model. And, I talked about initial conditions and how some things are, kind of insignificant. By just accurately looking at the pattern and understanding how to make adjustments, we were able to eliminate a tremendous amount of cutting and cost. I mean, this is not by any means the most significant opportunity or impact from the plugin, but I think it allows users to understand a whole new world of fine-tuned opportunity that can happen during the design process. So to kind of summarize, we've talked about this evolution of design and where we are in the BIM cycle. The traditional design process, it's 2D. It produces a lot of RFIs, change orders, value engineering. It's somewhat inefficient. It's got a cycle time of months. If we want to process changes through this methodology, we're really looking at something like months. The current state, which exists in various forms, but let's say we're in the BIM world now. The method is BIM modeling. The process of handling changes is clash detection, coordination. It's a great improvement over the RFI and change order process, and it's really reduced our cycle time. This is the return on the type of construction tech that's being used today. We can do this now in days and weeks. What we're exploring and what I think we're bringing into the market now is automated modeling. Now we just need to modify our input. So change our design assumptions and recycle the model in minutes, maybe hours for a very large project, but we're really looking at minutes now. So it's really quite a leap forward. And with that, I think what I want to do is just turn the conversation a little bit toward the development and some of what we've done there. I think the world that we're in now is one of really taking advantage of computers and processing through sophisticated software. There's a lot of challenges in getting there, but I think we can see that it's worth it. So, Apurv, I'd like to bring you into the conversation at this point. Tell us a little bit about what is required to, from the development standpoint, to bring solutions like this into the construction tech world.
Yes, sure, Tom. Thanks for the elaborate information about the application that we have developed. And we have faced a few of the issues or a few of the challenges while developing the application, like Revit-based platform or Revit-based plugin, which has some of the fundamental geometrical algorithms written into it, such as mechanical joints or bond cuts available within it. As well as we faced major challenges for pattern alignment, as there is not a really good documentation available around it. And we were able to tackle that to show a very realistic looking face patterns on face of walls, as well as we have created a software architecture which helped us to create a model platform for future expansion of the current plugin into technologies like Forge or web technology. As well as we have supported 3D data handling and 3D data visualization to support any kind of shape and orientation of masonry as well as units. We have used different Revit APIs like a schema for storing information within the project so that the project can carry all of its information related to masonry, which BIM doesn't support within itself. We also have created a complete ecosystem for the product, such as CRM, licensing, analytics, to be able to have a sustainable product and manageable product, and to be able to scale that product to a better extent. So those were a few of the challenges that we have faced during development.
Yeah, so you can see, I mean, it's been a very exciting journey. There's been a lot of interesting problems to solve along the way. But I think maybe to kind of wrap up, it's a very exciting time to be in construction tech. There's a lot of interesting things happening, but I really think some of the most interesting problems are still ahead. And so it's really fun to be partnering with people who are developing this technology and bringing it forward. It's an exciting time to see the impact that solutions like this are having. So with that, I think we'll wrap up the content. Anirban, we'll bring you back in. I don't know if there's any questions at this point? If there are, we've got a few minutes here. If not, we can wrap up.
Sure. Thank you so much, Tom, really for that intense and elaborative explanation of the product MasonryiQ, and I think that's been indeed quite a interesting product and sort of an pioneering product, especially in this domain of masonry. And yeah, I mean, of course, we are very happy to be part of the product development team who has been, helping develop this application. So it's great to see the success the product is receiving, from your customers and from the market in general. So. And yeah, I think, and thank you, Apurva, as well for your comments. I would probably request for any questions that the audience might have. Kindly do use the chat window to ask any question that you probably have for Tom. So please type in your questions using the chat window of the Q&A section. Okay, so I realize there are probably no open questions, and well, thank you everyone then for joining this webcast. And yeah, if you have any questions or if you want to know more about this product, kindly do connect with Tom Cuneio. He would be, I mean, after the webinar webcast is over, we would be sharing the details of Tom with his email ID and phone number in case you want to connect with him for any queries about the product. Kindly do connect with him. And if you want to build any applications using Revit, or any automation that you want to do using Revit, I think please do connect with nCircle to understand what are the possibilities and how we can help you build one. I'll be also sharing my details in the email. Kindly do connect, and we'll be happy to talk to you further. Thank you so much again. We'll close the webcast for today. Have a great Autodesk University ahead. I think we have probably another 2 exciting days ahead. So everyone have a great show. Bye-bye.